Thank you. Thank you very much. So I want to tell you a little bit about Starknet and also share with you some exciting numbers from our latest update to our Proofreader technology. So let's start. And I hope I'll have a little bit of time for questions. Please reserve them. Okay. So we've announced some time ago that Starknet, which is the most performant L2 on Ethereum today, is now reaching out to Bitcoin. And we will be the first layer 2 to scale safely in a decentralized way onto both Ethereum and Bitcoin. And you could ask, why isn't Ethereum enough? And the reason is that this is means to an end. The end is massive global usage of blockchain. And if you want to reach something like 1 billion users, which is just 1/10 of the people on Earth, you would need scale. And as you know, Bitcoin right now does not have scale to support your daily groceries purchase on Bitcoin. So it needs to scale, and we would like to help it scale. So you could ask now, why is this good for Bitcoiners? Why would they want a layer 2? So I want to give you an important answer. So Satoshi, when he wrote his white paper, talked about a peer-to-peer electronic cash system. So he envisioned something that would be just like cash. You can use it to buy your cup of coffee, which is something that today you cannot do on Bitcoin, okay? And it is something that needs to be fixed in order to achieve what Satoshi wanted. So that's reason number one. You also need scale in order to allow Bitcoin, to allow all of us to transfer our transactions or any transactions that we want from the fiat systems onto Bitcoin. And we today are very proud to boast the highest TPS on top of Ethereum. So these are numbers from a system in production. These are not predictions or on some testnet. These are numbers that have been produced in production, and we are right now upscaling our Proofreader technology, which should give us about a 3 to 4 factor X on top of this. So the other L2s that you'll see on Ethereum can max out at like 100 TPS, maybe reach 200. We're already 5 to 10X better than that and scaling up. We also have the lowest cost per transaction. We are 15X times cheaper than Arbitrum per transaction and similar factor with respect to base. So we are the cheapest and most performance L2 currently on Ethereum, and we want to expand this, of course, also to Bitcoin. So another reason why this is good for Bitcoiners is that part of the reason you don't see Bitcoin in massive usage today for your daily transactions is not just the scale, it also has to do with the UX. And there we can offer a much improved experience for Bitcoiners. So I want to give you an example. This is a wallet on Starknet. This is how you use it. So all of our wallets on Starknet, thanks to 100% native account abstraction, have biometric-enabled signing, even though they're fully self-custodial. So you own your keys, but the way you interact with the system is not by recording 24 words and connecting some USB. You just do it with your smartphone or with your laptop, as you do with other things, even though it's fully self-custodial. This is thanks to the high scale that Starknet offers and the 100% native account abstraction. So I want to give you another example, again, of a system in production. This is how things look today on Starknet when you want to do a bunch of DeFi things. So let's see this movie that we'll show. So this is how you swap on top of a DEX aggregator. And then if you want to do DCA, which is time-weighted, time-weight averaged swapping, like Uniswap, but over time, this is how you do it. You just enter the amounts, you can see the interface in UX. Again, these are systems that are in production today. This is not some mock-up of a system that one day will exist. So this is UX that you do self-custodially, exists today on top of Starknet. Today it is offered only to Ethereum users because we are currently an L2 only on Ethereum, but expanding it to Bitcoin will allow you to do similar things with this good UX and in a fully self-custodial way on top of Bitcoin. So that's a second reason. And the third reason is that many Bitcoiners would like to do more with their Bitcoin. So for instance, you would like to stake, you would like to trade, you would like to lend and borrow. All of these things you want to do in a self-custodial way, and you cannot do them today. If you want to do them today, you have to go through a third-party custody or a multi-sig. And we want to bring this to a world where you can do all of this self-custodially with good UX and massive scale. Now, you could ask, okay, so it's good for Bitcoiners. Why is this good for Ethereans? It's good for Ethereans because, well, there's so much value locked in Bitcoin, with all due respect to Ethereum, and I love Ethereum, and there's so much smart contracts and stuff to do on top of Ethereum that Ethereum can offer to Bitcoin. So there's a lot of stuff that can be done with the smarts of Ethereum on the value locked by Bitcoin. So that's another reason why this is actually good for Ethereans. And now finally, why StarkWare? Why Starknet? So the first place where
I'm going to tell you about a project that we're very enthusiastic about, and I think it can also
this is
help
from
the
2013,
Bitcoin
the first mention of ZK to scale Bitcoin.
On a breakthrough in theoretical computer science that I want to describe to you, especially focusing on the applications to the Bitcoin community.
So you may recognize that guy. He looks a bit younger. We were the first to talk about using ZK for scaling and for privacy, mostly for scaling. And this has been my dream since 2013. Now every day and everywhere people know that ZK is the end game for scaling blockchain, but we were the first to offer this. And in fact, I'm the co-inventor of Starks. Stark is the technology that everyone is now using, not just for post-quantum security, but also for scaling blockchain. So if you hear, about Polygon 3 or Risk Zero or Succinct, all of these solutions are using my technology, which I'm very proud of and very happy. But we have been at it the longest, and we invented a whole bunch of things that are now embraced by the whole community. We had the first production-grade prover, Stark Prover, already back in 2019. 6 years ago, we invented Validium, L2 rollups, proof aggregation, the aggregation layer. This is something that has been running in production on StarkWare's technology for 5 years. And we were the first to come up with a general purpose validity rollup deployed in 2021, recursive proving, layer 3, all of these innovations that you hear many people talking about, the first ones to show them in production and to ideate these things were us. So that's a very good reason why we are very well fit to scale Bitcoin. And yeah, also the first one to go on both Ethereum and Bitcoin. So we have a technology that is secure, trustless, decentralized, and we want to offer it to a strategic reserve. That's a very good reason why it should be us. And now I want to show to you some of our cutting-edge results in terms of, again, this is a production-grade prover. This is the first time I'm presenting these results. They're actually not final. So in a month, we'll have actually better results that the engineering team is just not comfortable sharing yet. So what you're seeing now is a sneak peek of Stu compared to some other Stark proving systems that are out there. Okay? So this is, the numbers I'll show you have been obtained by running benchmarks of our system compared to other leading systems on the same configuration. So it's a machine with 196 gigabytes of RAM, 24 cores, blah, blah, blah. You see the whole thing. So we ran all of these different systems on the same architecture, and we measured. And this is what we see. So it's very important for me to mention that the numbers you'll see here, even though they're already face melting, and they're the best out there, they're going to improve by significant factors within a month. So my engineering team was comfortable sharing this right now, just because I'm presenting it, but you'll see even better numbers. Not that they're bad. Okay, so if you talk about proving SHA-2, which is very important for Bitcoin, and we index it by the number of bytes that you're indexing. So the more bytes, the harder it gets. So here you have, so object means that this is compiled from software into a proof, and precompiles mean that there's a dedicated circuit that is optimized for proving it. And what you can see is that our numbers are pretty much the very best, and even better than comparable other systems which are using circuits, right? So this is code compared to circuits. Code should be less efficient, but we are more efficient. And then another example is SHA-3 proving time. So here again, this is like probably 20 to 30x faster, 20x faster than the precompiles, even though what we're using is actually code and not a precompile. So when we get to precompiles, things are going to be much faster. And this is even before we fully use the native field that we're using, that we're generating stew over, and this is without GPU optimizations, which are promised to give you a pretty significant factor over that. And another example, which is very important for AI learning, is matrix multiplication. So here, once again, you see that we are somewhere between like 5 and almost 10x better than the competing Stark systems. And this is code that is not yet finalized and will get only better. So that's another good reason why we are well suited to be those who are scaling both Ethereum and Bitcoin. And the reason we're doing this is in order to reach 1 billion users. And maybe I'll pause here for questions. I can go into a little bit more details about how does it work. But before that, I'll just pause and see if there are any questions. Any questions? Yeah, there's someone there.
I noticed on the first performance slide that jolt was much lower. What is that attributed to? Next.
Not here.
Yeah, there you go.
Wait, okay.
So on the left, jolt is like half. I was just wondering what that was attributed to.
You are right. The jolt is half. I don't know. These are the measurements. So jolt is half. Here it runs out of memory. I don't know. I got these numbers 2 days ago, so you're right. On this instance, jolt is half of this until it runs out of memory, and I don't know to what it's attributed. Here it's already worse, and here I don't know why I don't have it. Maybe they don't have the code for it. But other questions, please.
Yeah.
Yes.
So, thank you for the talk. I was just wondering, are you considering about ZKVM or any other solution that supports similar to SP1 and R0?
So we invented a ZK VM, the first to go into production, which is called Cairo. And it is extremely efficient and secure. It has a Rust-like interface, and it has very strong linear typing, and is also a blockchain language, meaning that you can write smart contracts in a very efficient way. So actually, ZKVM is another thing that we actually invented and productized first. And now a lot of teams are talking about creating VMs that are dedicated for fast proving. Been there, done that. But yes.
Another quick question. For the verification time, is it also very as efficient as the proving time?
Verification is much more efficient than proving. The whole way that a Stark system works is that verification is actually exponentially more efficient than proving, but I don't have the verification times here. As I said, I pressured my engineering team. I just got these slides a couple of days ago, and I just can present these numbers. But in a month, we'll present a whole lot of numbers on proving, verification, time, sizes of proofs, and stuff like that. So that's what I have right now to share. Other questions? Okay, I have a few more minutes, so let me explain to you one topic that we're often asked about, which is how exactly do you get what we call an L2 squared? How can you get to a system in which you can both settle onto Bitcoin and onto Ethereum in a way that is safe, where you can have situations where the two chains don't necessarily agree. So here's one way to do it, and this is, we're still actively researching it, but I just want to show you that something can be done. And the assumption I'm going to have here is that there is some assumed finality on both of the two chains. So both on Bitcoin, if you wait a certain time, and maybe it's 6 blocks, and on Ethereum, if you wait a certain time, you will be in a situation where there is finality, right? None of these chains will revert. But the finality times could be very different. In fact, they probably are. So now what do you do with the system in order to make sure that you don't have a double spend, like this irreconcilable states between the two chains? So here's one way to do it. So suppose you have reached your final new state on your L2, and let's call it S1. So now what you do is you put it on each one of the two chains, but you call it pending. You say it's not yet final. Now we wait on each of the two chains for the finality time to emerge. And then what we do is we go, assuming we have a light client for Ethereum and for Bitcoin, which by the way, we already have. So we have on Starknet a provable light client of Ethereum, and we are building a provable light client for Bitcoin, okay? So we already have one and the other will be built. What you do is you wait for the finality on Ethereum, and then you gather its proof of finality and you put that onto Starknet. You do the same thing with Ethereum, and the whole time the state is pending on both chains. Now you release state S2, and you can, together with it, prove that S1 has been finalized and accepted, and the finality time has passed on both Bitcoin and Ethereum. So now you send this to your two chains, and they will change the state from pending to final. And now, if you think about it, as long as there's no reorg that is longer than the finality time, then you will have this state where the two chains are completely in sync with respect to the layer 2, and you have finality, okay? So this is one way to address how to create an L2 squared. And this ends my talk. You're welcome to follow us. There's a lot of innovation and interesting things going on. There's actually a lot of initiatives related to Bitcoin that are actually coming and unlocking like every day, wallets on Starknet that support Bitcoin, the other way around, ways to generate yield with BTC on Starknet. So please follow us. Of course, if you're a developer, a Bitcoin developer, please consider building on Starknet, because this will be the place where you get expressibility, good UX, safety for Bitcoin. I have about a minute and a half. If there are any questions, happy to answer. Questions?